Okay, we're continuing our exploration of this first chapter for our course, thinking in terms of CNC coordinates, and now we're going to be thinking about CNC motions with 16.3. CNC machines move their axis in 5 different ways: rapid travel, linear, circular/linear, and 3D motion. And so all of these are the kind of things that we would need to make sure that we clearly understand. So when we go about programming them, we'll be able to do that. So rapid travel, we had a chance to talk about that previously, going from key points. Linear, we're just going in a single line. Circular, we're going in a single plane, having a circular travel. Circular and linear, it can be called 2.5D motion. The axis move in an arc while the third moves in a straight line. So that's what that can involve. And plus 3D motion. Few older controls have the ability to move in an arc using 3 axes simultaneously. Most approximate these arcs through the power of the CAM software. So that's a little bit of an insight into the kind of motions that we're talking about. Due to computer revolution with ever higher computing rates, most new CNC controls today can perform true 3D motion. So a little bit of a factoid here for us to be considering. Well, what about rapid motion? Rapid, as fast as the machine can move, but with the ability to reduce speed through operator override controls. And so here we have that ability, and we have a caution. So depending on the power of the CPU, your machine will rapid in 1 or 2 ways, but be sure to discover why in the text. The older controllers can take an unexpected route. So it may be easy to have an idea of how to program something, but you once again have to be thinking about what is the limitations of your machine that you're actually using. So think about that before you think about doing an override or other things when you're dealing with rapid motion. What about feed rate motions? The next 4 motions all move 1 or more axes at the machining rate specified in the program. The difference lies in how many arcs are involved in a straight line or an arc. As motions become more complex, the CPU must handle far more calculations per second by interpolating each axis drive commands. And you can see complicated motions can start to be more difficult. For feed rate motions continuing to move axes simultaneously to produce a constant velocity along the line AB, say at 400 inches per minute, neither the X or Y axis drives will move at 400 inches per minute. They will run at lower speeds that combine to create the tool motion of 400 inches per minute. So that's interpolating means to find an intermediate value, in this case, a feed rate value for each axis that combines to create the program rate. So here you can see an idea of what this means. So if you want to have 400, you can have a right triangle, and you can be thinking what it would then imply in the X direction and in the Y direction to come up with that program rate that we're looking for. You can also have feed rate override. The operator can override the resultant tool motion from 0%, that is no movement, to up to 100% or 150 in some machines. When the feed rate is changed by the machinist, the controller must change each drive proportionally to achieve the rate. Here you can be thinking in terms of circular interpolation. And so for an arc motion at feed rate, the controller is also interpolating as with linear. The difference is that it is constantly changing the ratio between the axis involved as the curvature changes slants. And so here what we're thinking about, you have a lot of these different XY determinations. And so you determine it for each little increment as you're going along. Okay, well, we'll just pause there, and then we'll get to our last increment of this chapter.